All right, so now we're going to take a look at adding and subtracting radicals. This is the only one that it's different, okay? It's very important for you to realize that you can only combine like radicals. Those are the radicals that look exactly the same. They have the same index and the same radicand. So in case you don't remember, the index is like whether it's a square root or cube root, and the radicand is the number or the variables underneath. Let's bring this back to third grade. First of all, what you're going to do is you're going to simplify to see if you can make it the same radical. It's just like combining like variables. So you did this in third grade. Pause the video. What is 2x plus 3x? Right, so you should have said 5x. What that means in terms of our radicals is if I had, let's say I had 2 radical 2 plus 3 radical 2, I can combine this because they have the same index, square root, they have the same radicand, which is the radical 2 part. So because I have the same radicand, the same index, I can combine those just the way I combined this. 2x plus 3x is 5x. 2 radical 2 plus 3 radical 2 is also 5 radical 2. So basically, it's like the radical is taking the place of the x. If you want to think of it, that's a way to make it easier. That's fine by me. So what you do is you add or subtract the coefficients. Those are the numbers before the radicals. So 2 plus 3, and you keep the radical 3, radical 2. All right. Or when you have unlike variables, so again in third grade, what would this equal? 2x plus 3y. Pause the video. You should have said that you can't simplify this or you can't combine it because 2 apples plus 3 oranges is not 5 apple oranges, right? It's still 2 apples plus 3 oranges. So in this case, you can't combine them. And you have the same thing in radicals. So let's say you had 2 radical 2 like the one before, but this time you have 3, and instead of radical 2, I just need it to be different. Let's say radical 5. Because the radicals, or the number underneath the radicand, all right, is not the same, I cannot combine those. Okay, so I can only combine if they are the same. Cannot combine if they're different. But sometimes when you simplify, they become the same. So let's look at a couple of examples. Again, please go ahead and draw in the square roots for me. All right, so I'm going to do example 1. Find the sum. What does the word sum mean? Adding. All right, so what are we doing? We're adding these two. All right, because we are adding, we have to be careful. We cannot add or subtract unless the radicals, this, is the same, and the radicand is the same. So 9 is not equal to 10. Right now, I can't add and subtract. But sometimes you need to simplify to see if you can make it the same. This means plus. So I'm going to just change that to plus because it says sum. Breaking down 9, I'm going to do this without the calculator at this point. 3 times 3, and those are both prime. This does 2 and 5, and I can't do anything anymore. All right, so now what do I notice here? So I'm going to write this out. I have 4, leave a space, 3 times 3, plus 3, leave a space for my books, 2 times 5. All right, do I see any books? Yes. On this first one, I have 2 cards, and because the index is invisible, 2 cards make how many? 1 book. Or if you're doing this in a different class, you can see a twin looks the same on the outside to everyone else. All right, on this one, do I have any books? No, I don't, so that's it. So 4 times 3, that's going to be 12. Nothing inside the radicand, so I don't need to write it. Then keep writing everything else, plus 3. Radical, and there are no books there, so 2 times 5, which is 10. So this does simplify down, but it doesn't simplify to where I can add it. So in this situation, I have this, unlike radicals or unlike radicands. All right, so 2 radical 2 plus 3 radical 5, I cannot combine. I cannot combine 12 plus 3 radical 10. Now, if this was 12 radical 10, then I could combine 12 plus 3, which would be 15 radical 10. But I can't combine this because they don't share the same one. So because I cannot combine them, and they're still, if I put this in the calculator, you'll see it's not a decimal that terminates or repeat. It's going to be irrational because basically they're not perfect squares. So irrational is because it cannot be written as a ratio of 2 integers, and its decimal expansion does not terminate or repeat. All right, so let's do another example, and then you're going to do 3 and 4. All right, so find the perimeter. Again, what is the perimeter? The distance around the entire shape. Okay, so I have 3 things that I need to add together, so I'm going to write those down. So I have 6 radical 28 plus 2 radical 7 plus radical 68. Okay, and again, right now, can I combine these? No, they look very, very different. This is 28 here, this is 7, this is 68, I can't. But sometimes when you simplify, you can. Use a calculator. At this point, I'm just assuming your prime factorization is strong. 2 goes into 28 14 times, 2 goes into 14 7 times, and I'm done. This one is done anyway. I just realized I forgot to change 68 to 63. So the question had changed and I did not write it. So this is 63. So I'm going to go do it off of 63. So I apologize about that. All right. So 2 doesn't go into 63, but 3 does. 3 times 21. Yep, it's 63. And again, you can do that with a calculator. This is 3 times 7. Okay, so I'm done. So that's everything, right? And as normal, you're going to write it all out, leave a space in order. 2 times 2 times 7 plus 2, leave a space, the 7 plus nothing, leave a space, 3 times 3 times 7. All right, let's take our books. All right, so 2 cards make a book because they're invisible 2. So I have a book right here. That's a book outside. Nothing else. No books there until the end. This is a book of 3. All right, let's write that out. So 6 times 2 is 12. Radical 7 plus 2 radical 7, because nothing happened in this middle one, plus 3 radical 7. All right, now we may have started off with different radicands, but now look at it, 7, 7, 7. So we have square root of 7, square root of 7, square root of 7. Because those are all the same, we can combine it. And the way you combine it is you think of 12 apples plus 2 apples plus 3 apples. So 12 plus 2 is 14, plus 3 is 17. 17 what? 17 apples, in this case, radical 7. So you combine the coefficients and you keep the radical. All right, so in this case, this would be still irrational. Why? Because if you put this in the calculator, you'll see it will be a decimal that does not terminate or repeat, because I still have this radical 7 piece. All right, so what I want you to do is you're going to do these 2 questions. I'm going to get you started. The side over square is radical 8. Again, go ahead and do that. So here is a square just for visual representation. This is radical 8. And I'm looking for the perimeter, so I'm going all the way around. So how many radical 8s are there? There are 4 radical 8s, right? Or you can say radical 8, and in fact, let me show you that. You can say radical 8 plus this radical 8 plus this radical 8 plus this radical 8. And I just went around the shape, which again, remember, if they're all the same radicals, so radical 8, I can add them. So this is, I have an apple. Now notice I said I have an apple. I didn't say I have one apple. It's the same thing, right? Whether I say I have an apple or one apple, it's the same thing. So I have an apple plus another apple plus another apple plus another apple. How many apples do I have? I have 4 apples. Now, it's very important that after you add, since I did not do the first step, because remember the first step is always to do what? Simplify. So in this case, because I added before I simplified, I must make sure that I can also simplify. So go ahead and simplify, prime factorization, so forth, and give me a final answer, then tell me if it's rational or irrational. All right, so again, I'm not going to be able to give you every single question anyone will ever ask you, so we're going to develop your thinking with this one. This question says, find the perimeter of the part of the image that has the arrows going around it. That's this side right here, okay? The large square is 32 feet squared, so this one's 32 feet squared. The smaller squares are 8 feet each. What is the perimeter? So in this case, I need to find what these sides are. So again, just think about it, because this is what maybe a test question would look like. How would I find the side of this square here if I know the area is 8 feet squared? What would this side be? What would this side be? Go ahead and label as I'm talking. What would this side be? What would this side be? Remember, this side right here from here to here is this box right here. So if the area is 32 feet squared, what would this side be? What would this side be? What would this side be? And then finally here, we're back on this box. What would this side be? And of course, to find the perimeter, you're going to do this. So whatever you wrote there, it's going to be that plus whatever you wrote there, plus that, plus this, plus that. And all of those added up will give you your perimeter of this rectangle. All right, and then as an applied question, once you find the perimeter of this rectangle, without reworking everything out, can you tell me what the perimeter of the entire image is really quickly? Let's practice.